All right, so this is the famous cone of death question from 2010. So this appeared on exam one, so we're doing this tech free. All right, so let's get into it here. We've got a cylinder that fits exactly into a right circular cone so that the base of the cone and one end of the cylinder are in the same plane as shown. The height of the cone is 5 centimeters and the radius of the cone is 2 centimeters. Radius of the cylinder is r centimeters. Height of the cylinder is h centimeters. For the cylinder inscribed, that is the cylinder inside the cone, what we want to do is find h in terms of r. So the students found this very, very difficult this year, and it actually involved using similar triangles. So what we're going to do is look at the similar triangles and see if we can identify them. All right, so first of all, what I'm going to do is look at the cone itself and note the distance across there and the distance across there match up with these distances that are listed here. So I'm just going to draw that right angled triangle. That's that one there. Oops, that's really hideous drawing of it. This is not much better, but it'll do the job. So we've got 5 and 2. So that's that big triangle there. Now what I'm going to look at is another triangle, and in fact a similar triangle. And for a similar triangle, what we have got here is the right angle. We've got this angle here. Let's call this, I don't know, whatever, theta. And what we want to do is find something that shares the angle theta. So another triangle that shares that angle theta. And what I'm going to use is this one at the top here. So if we imagine this triangle here, it shares theta. Okay, so I'm actually going to draw that triangle as well. So it's a smaller one, so I'm just going to draw it smaller. Now, what do we know about this? Well, it tells us in the question that the radius is r, so the distance from there to there is r. I'm just going to note that by putting that as r. What we need now is a height, and we need the height of that. Well, if we know that this is 5, and we know that the height of the cylinder is h, we know that this is h here, then the distance from here to here is also h, which means this distance here must be 5 take h. So once I know that, I can actually plug that in, 5 take h. All right, so now what we're going to do is understand that the ratio of these side lengths for similar triangles will be exactly the same as the ratio of these side lengths. So let's establish the ratio by going the ratio of 2:5 on this triangle here is the same as the ratio of r to 5 take h. So what I'm going to do is rewrite that as a fraction. So that's 2/5 is the same as r over 5 take h. All right, so now what we're going to do is cross multiply here. So I'm left with 2, 5 take h equals 5r. All right, now I want to find h in terms of r. So I need to make h the subject. So I'm going to divide by 2. So I'm left with 5 take h equals 5r on 2. Now what I'm going to do is say negative h equals 5r on 2 take 5, and I'm going to divide by -1, so that means that h is equal to 5, take away 5r on 2. So there's my height there in terms of r. So that was the one that students found extremely difficult. I can't remember the stats, but it was like 10% of the state could get that right. Most students didn't or couldn't use the similar triangles, hadn't done it recently enough, hadn't practiced a question like this. Right, so let's go over the page and have a look at where this went after this. So the total surface area S for a cylinder of height h and radius r is given by this formula here. Find S in terms of r. And that means that this h here is the one that we found earlier. So we noted that h is equal to, and I've forgotten the value, so I'm just going to scroll back up again, is equal to 5 take away 5r on 2. So what I'm going to do is, if they want me to find S in terms of r, I'm going to quickly sub in h here. So S is equal to 2 pi r, 5 take away 5r on 2, plus 2 pi r squared. All right, so I'm not sure whether we would need to expand this out, but I certainly would for the 1 mark. I wouldn't leave this unfinished. It sort of seems unfinished, even though S is currently in terms of R. We're going to say that this is S equals. Now, let's expand that out. So we've got 2 pi, not 2 pi, so S equals, so 2 pi R multiplied by 5 is 10 pi R. Take away, these twos cancel each other out, and we've got 5 pi R squared plus this 2 pi R squared. S equals 10 pi R, take away 3 pi R squared. Right, so look, if you didn't do this here, I still think that you get the mark if you leave this line like this. I'm not 100% sure about that. I would make this move, but I think you'll get the mark at this point here, okay, with 1 mark and S in terms of R successfully done. But you would have had to do that anyway, because this question here says find the value of R for which S is a maximum, okay? So if we're using this function here, what would I have to do is if I wanted to find out where it's a maximum, I get the derivative, ds dr, and to do the derivative here, I really need to get these out as single terms. So I would have had to expand it out anyway when it got to this point here. So we've kind of saved ourselves the trouble by doing it here. So I'm just going to note that S is equal to 10 pi R, take away 3 pi R squared. I'm just restating that. And now what I'm going to do is find the derivative, which is ds dr equals 10 pi, take away 6 pi r, and the maximums or turning points occur when ds dv, or the derivative, is 0. So 0 equals 10 pi, take away 6 pi r. Negative 10 pi equals negative 6 pi r. R is equal to negative 10 pi over negative 6 pi. Pi's cancel out, negatives cancel out. R is 10 on 6, which is 5 on 2. Whoops, that's a really tragic mistake there, right at the end, 5 on 3. All right, so there's our cone of death question, and not too bad when you get into it.